Hello students, let us start with another easy and important topic called areas related to circles. It is a revision of the concept related to area and perimeter of circle. Along with that, you will be having the formulas to find area and perimeter of a semicircle, sector and a segment. So let us recall, we have learnt perimeter and area of circle. Perimeter of all plane figures is the outer boundary of the circle. Likewise, the outer boundary of circle is the perimeter of the circle, and it is known as circumference of the circle. The circumference of a circle is given by the formula 2 pi r pi d, where pi value is taken as 22 upon 7, where r is the radius and d is the diameter, which is twice the radius. Recall, we have learned area of the circle enclosed by circumference. It is given by pi r square. Look at the figure. R is the radius, D is the diameter. The area enclosed by the circumference is pi r square, and the circumference of circle is 2 pi r. Let me take up an example. If a pizza is cut into 8 equal parts as shown in the figure, then what is the area of each piece of pizza? The radius of the circle shaped pizza is 7 centimeter. Here 7 centimeter is the radius. Here the pizza is divided into 8 equal parts, so area of each piece is equal. Area of one piece will be 1 by 8 of the circle. 1 by 8 times pi r square, so 1 by 8 to be multiplied with 22 by 7. Here r square is 7 into 7. The unit will be in terms of centimeter square. Hence, we get 77 upon 4 centimeter square. Up semicircle. Here, in the semicircle, the circumference will be exactly half. Along with that, it is also having a diameter. So perimeter of semicircle is half the circumference of the circle plus the length of diameter, as perimeter is the outer boundary of the figure. So circumference of semicircle is 2 pi r upon 2 plus d. So we get pi r plus 2r or pi r plus d. It can also be written as pi r plus d. And the area enclosed is exactly half of the circle. So area enclosed is pi r square by 2. Now we have two concentric circles and the region between the two concentric circles. We have also named it as ring. Let us recall area of the ring. Area of a ring. Let me take up two concentric circles. Here the smaller circle or inner circle is having the radius small letter r, and the larger circle, which is the outer circle, is having the radius capital letter R. So the area of ring is the colored part in the above figure and is calculated by subtracting the area of inner circle from the area of the outer or the bigger circle. So area of ring is pi times capital R square minus pi times small r square. Pi being common, it's pi times of r square minus small r square, where r refers to the radius of outer circle, which is capital letter R, and the small letter r refers to radius of inner circle. These were the concepts we had learned in our lower classes. Now we have in class 10th the topics which are added up are areas of sectors. The area formed by arc and two radii joining the endpoints of arc is called sector. Here there are two sectors. If I consider ACB as the arc, with respect to arc ACB, we have got minor arc. With respect to arc ADB, we have got major arc. The area enclosed here is ACBO, which is minor arc. The area enclosed ADBO, it is major arc. Area of minor sector, the area including angle AOB with point C is called minor sector. So OACB is minor sector. Angle AOB is angle of minor sector. If the angle of minor sector is taken as theta, with respect to theta, if this angle is taken as theta, theta by 360 into pi r square will give area of minor sector. It is something like this. If we have a circle, the angle which is formed at the center is 360 degree. For 360 degree, the area is pi r square. For angle theta, how much? It will be theta by 360 into pi r square. This will be the area of a sector. Here the angle theta is taken as angle in the minor sector, so we get area of minor sector as theta by 360 into pi r square. From the total area, if you subtract this theta by 360 into pi r square, we get the remaining. That remaining is nothing but area of major sector. Area including angle AOB with point D is called major sector. OADB is a major sector. The angle of major sector is the angle 360 minus this theta. So area of major sector is given by area of the circle pi r square minus area of the minor sector. In other words, when we add these two areas of the sectors, we get complete circle. What about the length of the arc? The length of the arc of a sector having the angle theta is given by theta by 360 into 2 pi r. As I mentioned, if there is a angle formed 360 degree, we get a circle. So for 360 degree, what is the circumference? 2 pi r is the circumference. If there is an angle theta, what will be the circumference or the length of the arc? The length will be theta upon 360 degree into 2 pi r. Now let us take up segments. Area of segments of the circle. The area made by an arc and a chord is called segment of a circle. Observe in this figure, arc AXB and the segment and the chord AB makes minor segment. This part which is in yellow color is a minor segment. The arc, if you consider as a major arc and the chord, that region is called as major segment. If I consider a minor segment, the area made by the chord AB and the arc X is called minor segment. The area of the minor segment is calculated as area of minor sector minus the area of triangle ABO. If this triangle's area is removed from the area of the sector, you'll be getting area of the segment. In the earlier discussion, we learned theta by 360 into pi r square as the area of sector minus half of r square sine theta. For a major segment, we need to subtract the area of minor segment from the area of circle to get area of the major segment. In few cases, there will be combination of plane figures. As we know how to calculate the area of different shapes, so we can find area of the figures which are made by the combination of different figures. For example, find the area of the colored part in the given triangle is equilateral and its area is 17320.5 centimeter square. Three circles are made by taking the vertex of the triangle as the center of the circle, and the radius of the circle is half the length of side of the triangle. Taking pi equal to 3.14, root 3 as 1.73205 to let us find area of this colored part. This colored part is not a polygon. This part is obtained by the combination of the parts of the circle which are sectors. So area of the triangle minus area of three sectors will give the result. Here they have given that the triangle ABC is equilateral. If it is an equilateral triangle, all of those angles, angle A, angle B, angle C, is 60 degree each. Here we need to find area of shaded or colored region or colored part. This will be equal to area of triangle minus area of three sectors. They have mentioned the area of triangle. Area of triangle is given. Area of triangle ABC is given. It is 17320.5 centimeter square. I know that it's an equilateral, so root 3 by 4 times side square will be 17320.5. So I can find the side square as 17320.5 multiplied to 4 divided by 1.73205, because they have given root 3 value is 1.73205. On simplification, we get it as 4 times 10 square, sorry, 10 raised to the power 4. So side will be 2 times 10 square, which is 200 centimeter. So we have found the side. Now we require area of sector. How do we find area of sector? For that we require radius. Here a radius of sector is half of length of triangle. Just now we have found the length of triangle as 200 centimeter. We get it as half 100 centimeter. So area of sector will be equal to theta by 360 multiplied to pi r square. So 60 degree upon 360 degree multiplied to pi times 100 square. We get it as 1 by 6 times 3.14 multiplied to 100 into 100. On further simplification, we get it as 15700 upon 3 centimeter square. This is area of one sector. So now the final result, area of colored part will be equal to area of triangle ABC minus 3 times area of sector, one sector. So we get 17320.5 minus 3 times of 15700 upon 3. This 3 get cancels. We'll be getting 1620.5 centimeter square. Let's try and understand another example. Find the area of shaded part. If the side of the square is 8 centimeter and 44 centimeter, here there is a correction, and the circumference is 44 centimeter. Here area of shaded part will be equal to area of circle minus the area of square. Circle's area is pi r square minus side square. How do we find area? To find the area, we do require radius. They have given circumference as 2 pi r, which is 44. So r will be 44 divided by 2 pi. So we get 7 centimeter as a radius. Therefore, area of circle will be 22 by 7 into 7 into 7, which is 154 centimeter square. How do we find area of square? Area of square is side square. They have given the side as 8 centimeter. So 8 square is 64 centimeter. Therefore, area of shaded part will be 154 minus 64, which is 90 centimeter square. That's all for today's session. We shall take up the questions from the exercise in the next session onwards. Thank you.